All right, so finally in this segment, we're going to take a look at more interesting examples of finding a limit. Starting with the one we see right here, let's find the limit as x approaches to 2 of x squared minus 4 divided by x minus 2. Now, if you follow the approach taught in the last segment, that was mainly for continuous functions, and you substitute x is equal to 2 everywhere you see an x in this function, what would you get? So in the numerator, we have 2 squared minus 4. So 4 minus 4, that's 0. In the denominator, we have 2 minus 2, another 0. So what we have is 0 over 0. So in mathematics, we have a special name for this. We call it indeterminate. And that does not mean that the limit does not exist. It basically means that we need to do more work to figure out what's happening. So 0 over 0 for a limit question means the limit is indeterminate at the moment, but more work needs to be done to explore it. So we're going to apply 3 different approaches to solve the problem. One of them will be the analytical method. Now, the analytical method basically is also known as the algebraic method, is using equations to simplify the expression. So plugging the number in for a limit question is pretty much always a good idea. And if you get a number as an answer, run with it. That's your answer. It must have been a continuous function. If you get a weird situation like division by 0 or 0 over 0, then try to do something to simplify the expression. In this case, I can factor the numerator, right? So x squared minus 4 is the difference of 2 squares. It's x minus 2 times x plus 2. So again, simple algebraic factoring, right? X squared minus y squared can be factored as x minus y times x plus y. And if you need any reminders about this, just FOIL this and you will see the inner plus outer terms will cancel and you'll be left with that, right? Simple factoring reminder. Denominator is x minus 2. Now at this point, we can cancel the x minus 2's and we're left with x plus 2. And at that moment, take a limit as x goes to 2 of x plus 2. That means substitute the 2 in and you get a 4. So we got rid of the indeterminate case and now we have an answer. So the answer to the original limit question is 4. Now that approach, while it's pretty efficient, doesn't really tell you what's happening behind the scenes. Sometimes it's good also to look at a numerical approach or even a graphical approach. For the numerical approach, if you have a TI calculator, press your y equals button on the upper left, and for y sub 1, enter the original expression, which is x squared minus 4 all over x minus 2. And then to get a table, basically what we want to do is with the numerical method, since we're going to approach to 2, ideally we want to approach to 2 from the left and the right. As we approach from the left, we may pick a value like 1.9 and not up to scale here, but let's say 1.999 and 1.999. Approaching from the right, I might select 2.1, 2.01, and 2.001. So I want to see what's happening to the f of x values as x approaches to 2 from both sides. So basically, I need to know my x values and f of x for each of the given x values. Say 1.9, I could plug it in here for x. And even if I didn't have a table, I can certainly evaluate this using a basic calculator. But if you do have a calculator that has tables, it's just going to make your job that much easier because you can very efficiently find for all of these x values the corresponding y values. So if you have a calculator, graphing calculator, so for your y sub 1, enter this. And then you would go to your table feature. So usually on the very upper part of your calculator, right here usually is your maybe like second. So right there is your table, but before you go to table, you may want to do second window, if I remember correctly, is your table settings, because you want to select dependent variable. Select that one as ask. And independent variable, that's your x, select it as auto. So if you choose these settings for your table settings, it will allow you to enter the x values manually. So I would begin by entering x equals 1.9, then 1.99, and so forth. Notice that at 2, you should get an error because it's not really defined at the point 2, but that doesn't matter. We can still find the limit. And approaching from the right, I'm going to select values like 2.1, 2.01, and 2.001. Sorry, actually I stand corrected on my description for the calculator. So dependent is really your y variable, and we want that one to be automatically calculated for you. So the dependent one, make that one auto, please, if you want to do it an efficient way of calculating these. And then the independent one, that's your x. And that's the one we want the calculator to ask us so we can actually enter those values manually as we choose. Because if you don't do that, it will enter its own like 1, 2, 3, whatever starting point and increment is. But this is the correct settings. If you're using a calculator, graphing calculator, please use these settings. So I've already entered those values on the calculator, and this is what I got. As a matter of fact, my graphing calculator on the computer did not work today, so I went to a website called desmos.com. It's a really neat graphing calculator. It's free and online, and you simply just type y equals, and in parentheses you type your expression. You use a division sign from your keyboard over x in parentheses x minus 2, and it gives you the graph right away. And if you click on the settings and click on the table, it will convert that into a table, and it will give you a way to enter your x and y values. So if you don't have a graphing calculator available with you, like I did not in this case, you can just go to desmos.com. So these are the results we're getting for the y values. So as x goes to 2 from the left hand side, the y values are getting bigger and bigger, approaching towards 4. And as you approach from the right hand side, 2.1, 2.01, 2.001, the y values are approaching towards 4 once again. So it looks like from either direction we're going to get the same y value. So even though it's not defined at that point, they're approaching clearly towards the value of 4. So once again, we get the same answer with the numerical method. So we've confirmed our result from above. And finally, let's do the graphical approach. This time you would graph the function. Now you can graph this one easily by hand because you know that when you simplified it, you end up with y is equal to x plus 2, which is a very simple linear function, right? Y equals x plus 2. It will cross the y-axis at 2, and it's going to have a slope of 1. So this is going to be the graph. And at the point of 2, actually, technically there's going to be a hole in there in the graph, but the graphing calculator may not be able to show you that. So this is what the graph looks like. And technically, if we want to make it very accurate, we should really put a little hole across from x is equal to 2. So when x is 2, y is technically 1, 2, 3, 4, right there. Technically, there's a hole. And if you want a proof of that on the calculator, just press your trace key. And then press, right after that, press the number 2 and enter. At that point, it will tell you x is 2. And for y, it's going to give you a blank, like there is no y value defined at that point, which we, of course, knew. So graphically also, we can see that even though there's a hole right there, as you approach from this side and as you approach from that side towards x equals to 2, we see that y values are converging at the point 4. So once again, limit of our function as x approaches to 2 is equal to 4. So all three approaches, we get the same answer. And so you might say, when can I use which approach? So usually, usually I will ask you to use the analytical method and use one of the other methods to check and confirm your answers. But usually I'm going to want to see the algebraic method included. Occasionally, if there's a very high degree function, say fourth degree, fifth degree, and it cannot be factored, in that case, I would say, okay, use any other method. So it's important for you to know how to use your calculator to be able to get an answer in case the function cannot be factored. But be prepared to show all work. All right, so let me give you a few moments to solve this example. So a similar question, and then we're going to take a look at the answer. So hopefully you took your time to practice this on your own. And let's check your answers. So if you plug in a 4 into the numerator, you're going to end up getting ultimately 0. And on the bottom, same thing, 0 over 0, which is indeterminate. So you may want to factor the top and factor the bottom. And the way you can factor the top is into two binomials, x minus 4 times x minus 1. So again, a quick way to check that is these two multiply to plus 4. And then if you do inner plus outer, negative 4x minus 1x, that should give you the middle term here, which indeed does, negative 5x. And factor the denominator as well. So x squared is x times x. For factors of negative 4, you may want to choose negative 4 and positive 2, which will multiply to negative 8. And the inner plus outer terms will give us what we need, which is negative 2x. So those are the factors, negative 4 and plus 2. So notice that these are going to cancel now. So we're left with x minus 1 over x plus 2, at which point, go ahead and try to plug the number in. We're taking a limit as x goes to 4. So 4 minus 1, we get a 3 on the top, and 4 plus 2, we get a 6 on the bottom. So the final answer is 1/2. All right, here's another example. This one is a bit unusual. So here you have a function given as a piecewise defined function. It's defined as x squared plus 1 if x is different than 1. And if x is equal to 1, it's defined as 3. So let's first try to imagine what the graph of this function might look like. This is a quadratic function with a plus 1 added. It's been pushed 1 unit up. So I would begin by graphing the U-shaped curve through 0, 1 and going upwards from there. So normally you would begin with that. But then at the point x is equal to 1, what does your quadratic function give you? If you plug in 1 for x, you will get 1 squared, which is 1 plus 1, you will get a 2. But this is suggesting that the answer should be a 3. So the only difference between this and the typical x squared plus 1 is going to be 1 point. So across from x is equal to 3, we're going to observe a point of discontinuity, basically. Okay, let me get rid of this cover. There we go. Okay, so here we have y equals x squared plus 1, a U-shaped curve moved 1 unit up. But we must adjust the graph at the point x is equal to 1. We're going to put actually a hole in the graph, an exaggerated open circle. And instead, the filled in point across from x is equal to 1, where should that be? At x is equal to 1, the function is defined as 3. So the filled in circle should be across y is equal to 3. Okay, so this is our graph, and now let's figure out what is the limit as x goes to 1. So this function is not continuous at that point, but as you approach to 1 from the left-hand side, and as you approach to 1 from the right-hand side, where are the y values approaching? And the answer is 2. So if they had asked us what is the function value, what is f of 1? The answer is 3, but they did not ask us that. They said, what is the limit as x approaches to 1? And there, the answer is 2. All right, another analytical example. All right, let's take a look at this one. This one involves difference of two cubes, and I'm reminding you the formula at the top there in case you forgot. And if there's a cube plus b cube, it will be very similar, but the first one will be a positive, negative, positive. So if you see a cube plus b cube, it'll be factored almost exactly the same way, except signs are going to be a little bit different. All right, so let me give you a moment to do this, and then please come back to check your work. So when we factor the numerator, remember your 27 is the perfect cube of 3. So your b in this formula will be 3, right? So first one will be x minus 3 multiplied by quantity x squared plus ab will be for us plus 3x, and plus b squared will be the square of 3, which is 9. Denominator is the same, and I didn't even mention it, but you would always be encouraged to plug the number in first, and in this case we're going to get 0 over 0. That's why we need to simplify it further, and that's what we're doing here. Notice the x minus 3's can be canceled at this point, so we have just this trinomial, and you can substitute 3 into there. So plug 3 in. So you get 3 squared plus 3 times 3 plus 9. So you're going to have basically 3 nines or 27. And one thing I want to point out about proper notation is notice that throughout this process, I'm keeping my limit symbol. I'm keeping my limit symbol. And the only time the limit symbol disappears is when you actually substitute the value in for x. When that happens, at that point, you no longer need to mention the limit symbol. But again, it's very important to write proper mathematics at this level of a math class. So please make sure you always put your equal signs, your limit notation, and it's nice to even put your equal signs aligned together if you can. That's not as important, but the important part is that make sure the limit is in there. All right, one more example about determining limit of a function that is not continuous, and this one involves radicals. I would encourage you to think about this problem a little bit. Plug the number in, see what you're getting, see what kind of a simplification you can do, and then we'll discuss the solution. So for this question, if you tried to substitute 6 for x, you're going to get square root of 6 minus 2. Minus 2 on the outside. On the denominator, 6 minus 6, or 0. In the numerator, square root of 4, which is 2, of course, so 2 minus 2, which is 0. So once again, we're having a situation of 0 over 0, which we learned is indeterminate, so we're going to try to get rid of that. But how do you factor this? Of course, you could use the analytical, the tabular method or the graphical method here. And in problems like this, it may not be a bad idea to check your work that way. However, for this question, we're going to try to use the analytical method. And here is a tip for you. When you're dealing with radical expressions, one way to simplify it is going to be to multiply top and bottom by the conjugate of your radical expression. So the one that has a radical, in this case, is the numerator, and the conjugate of that is the one that has the opposite sign in the middle. So in general, if you have the square root of, let's say, a plus b, the conjugate will be square root of a minus b. So you look at this sign in the middle, and you turn it to its opposite, and you have the conjugate. And it can also look like this, square root of a, let's say, minus square root of b, and the conjugate of that will be square root of a plus the square root of b. So what the idea is multiplying the top and bottom by the conjugate. Now that you have that hint, it may be a good idea for you to try to finish the problem, and please come back to check the solution. So I'm going to multiply the top and bottom by the conjugate. So because I'm multiplying top and bottom by the same quantity, it's like multiplication by 1. It doesn't change the value of anything, but it's going to help us transform the numerator into a simpler expression. Now notice that the numerator can be written as a minus 2 times a plus 2. So basically it looks very much like difference of two squares, right? A quantity minus a number times a quantity plus the same number. And the first quantities also match. So this is going to be difference of squares. You could certainly FOIL it out and you will see the middle terms cancel out. But the easiest way to do this is to remember your formula for difference of squares, which is a minus b times a plus b simplifies to a square minus b square. So with that in mind, multiplying the two numerators, square the first one. So the square of x minus square of the square root of x minus 2, you lose the radical, just x minus 2. Minus b squared, so square the 2, and that's 4. In the denominator, don't even simplify it yet. Just rewrite everything as you see it. X minus 6 times quantity square root of x minus 2 plus 2. At this point, just simplify the numerator and you will see why we kept the bottom unchanged at the moment. So x minus 2 minus 4 gives us x minus 6. So now you see, right? So because we can cancel the x minus 6 from the top with the x minus 6 from the bottom. So these are being multiplied. So it's legitimate to cancel them at this point. So there's going to be a 1 left on the top and the radical expression left on the bottom. So once we do that, at this point you can plug the value in, x equals to 6. And when you do that, 6 minus 2 is 4, square root of 4 is 2, plus 2 on the outside is 4. So the final answer to this question will be 1 over 4, which you can check using numerical approach. Finally, I'm leaving you with one more problem using radicals. This one, I'm just going to show you the answer in the next few moments. So please try this on your own before you take a peek at it. Okay, this is your spoiler alert. In the next page, I will have the entire solution to this. So if you haven't worked it out yet, this is your last chance to pause the video. And here we go. I will multiply the top and bottom by the conjugate. That's going to have a plus 3 in the middle. Then distribute the numerator. Again, you have a minus b times a plus b. Use difference of squares formula, which is a squared minus b squared. Denominator, keep it the same. Just write them next to each other. Simplify the numerator. 4 minus 9 is negative 5. Now, when you cancel negative x minus 5 from the top with x plus 5 on the bottom, just notice that this is negative 1 times x plus 5, so there's going to be a negative 1 left behind when you cancel those. Denominator also has reduced because we canceled the x plus 5. Finally, plug in the limit of negative 5. Don't forget 4 minus negative 5 will be 9 under the radical, and then simplify it. The negative 1 on the top remains, and the bottom will be 6, so negative 1 over 6 is your final answer. So hopefully you've seen plenty of examples on limits by now and have given you enough information to tackle your homework problems on limits. See you next time.